creating a Roman numeral converter using test-driven development. You can see the end result here. We can enter in Arabic numerals and get Roman numerals. And if we enter invalid numbers, we get some error messages. Okay, so we're going to start with an empty directory, which we'll call Romanizer. And then we'll cd into that, and we'll run npm init with the Y flag, which automatically answers yes to all those questions it likes to answer. And then we're going to install some dev dependencies. So we use the save dev flag, and we're installing tape and tapspec. Tape is our test framework, and tapspec is just a formatter for the output of tape to make it look a little nicer. I'll show you the difference between them in a sec. So we'll open up our project in Atom, and then have a look at our package.json file. You can see our dev dependencies listed there, tapspec and tape. So I'm going to add an npm script for the test command, and that's going to be tape, and then we'll give it the file we haven't made yet, our test file, which is romanizer.test.js. Okay, now if I create that file, we need to import the tape library. So we'll use require for that and assign it to the test variable. So we now have access to tape using the test variable. So we'll call test, and then we'll describe what we're testing. In this case, we're just going to check that tape is working. That takes a callback. And then inside there, we can do our tests. So we'll just do a basic 1 equals 1. And we'll say 1 should equal 1. And t.n tells tape that we're done with our tests. So now if I run npm test, we get the result, which is that our tests pass 1 out of 1. But this isn't particularly nice to look at, and it's quite hard at a glance to see what's going on. So we're going to use tapspec to make they look a little better. We'll use the pipe command, which just takes the output of this and sends it into whatever is after the symbol. In this case, that would be tapspec. And now if I run the same command again, you can see it looks much cleaner. There's color and ticks, and you can just at a glance see what's happening, which is great. So we're going to be using test-driven development today, which means that we're writing tests before we write any code. So we need to think about what we want our function to do, what it should take in, and what it should output. And we want this function to take in a number, say 1, and we want it to output a string, in that case, which will be I. So for our first test, we can say 1 should, well, actually this is describing what the test is testing, so Romanizer output is, let's just say Romanizer output for now. We'll give it the callback, and we'll say that our actual result is Romanizer, and let's call it with 1, and then our expected output is going to be I. And then t.end again tells tape that we're done testing. This isn't actually going to run right now because we don't have access to Romanizer in this file. We need to import it in the same way that we imported tape here. So we're going to do our Romanizer equals require, and then we haven't made the file yet, but it will be at this path. This is just the directory we're currently in. This is the file which I'll create now. So Romanizer, oops, that's the giant new touchpad for you. Romanizer.js. And in here we'll need a function called Romanizer that takes in a number, and for now it's not going to do anything. And then in order for our test file to be able to import it, we have to export it here. So for that we use module.exports and set that equal to the Romanizer function. And now hopefully when we run our test, getting the second test running for some reason. I wonder why that is. Oh, I haven't actually done any comparison inside of the test. Yep, make sure you actually test something. So t.equal actual should equal expected, and here we expect 1 to output I. Okay, now if we run that, there we go, we've got one failing test. One should output I, and if you see up here, expected I, but it got undefined. And that's because we're not returning anything from our function right now. So the way TDD works is we now have a failing test. We need to make that test pass by writing some code. So in the simplest way possible, I'm just going to say return I. And now if we run our test, there we go. We have two passing tests. This seems a bit counterintuitive because obviously this code isn't going to keep working. As soon as I write more tests, this is going to be failing again. But the idea with the TDD is that you keep writing as little code as you need to pass the current failing test, and then build and build on that until you reach your final solution. So we're going to try and keep relatively strictly to that for today. So now we'll test to see what happens when we give Romanizer 2. So we're testing the same thing again. And this time we're going to say actual is Romanizer 2. And we expect to get II. Let's make sure we actually test something this time. And 2 should output II. And we'll just give it t.end, so tape nodes to finish. Now this test should be failing. Typo there. There we go. 2 should output 2, but we're getting, 2 should output II, but we're getting I. And that's because we're only returning I. So the simplest way I can think of to solve that is to say if the number we give it is equal to 2, we return II. And now running the test passes. So 2 should output II, and it is. Just a quick aside here, I'm getting slightly annoyed running npm test over and over by myself, so I'm going to install a module called nodemon, which is a daemon that watches your files and then reruns everything when it notices that files change, so when you save a file. So once that's installed, I'll just tweak our test script to use nodemon instead of tape. And then it should hopefully just watch our test file for us and then update every time we save it. So now if I run npm test again, there we go. It runs the tests, and now nodemon is waiting for any changes. So for example, if I change that to break it, nodemon runs again and shows us our output. So I don't have to keep running npm test. Okay, so we have it working for 1 and 2, but we can see that this probably isn't going to work. And if I create one more test, I'm just going to start copying them now. For 3 should output I. Obviously, yeah, that's going to fail. We can see that. So what we need to do is refactor our code to try and find a way of abstracting out some of the repetition here, because obviously we could just do the same thing again and have an else if 3, but this is getting unwieldy and obviously we're going to have to keep doing it. So generally we can abstract if statements that have shared logic like this out into loops. So what we're going to do instead of this is we're going to have a result variable, which is just an empty string to start with, and then we're going to have a while loop, and we're going to say while the number is greater than 0, add an I to the result, and then we're going to return that result. And we should be able to get rid of all of those if branches now. Oh, one more thing I'm missing. We need to decrement the number as well, otherwise the while loop will never end. And unless I'm doing something stupid, yep, our tests now pass. So we managed to abstract out all those if branches into one loop. So refactoring has helped clean up our solution here. So let's keep going with the TDD process and see where it takes us next. We're going to check for now. So let's say for should equal IV. And again, obviously this is going to fail, which is what we want. And now we need a way of making this work. So same as before, the simplest way to do that is just if number equals 4, then we return IV. And our tests are passing again. Okay, and you can probably see this is pretty much a repeat of what happened last time, but just for clarity's sake, I'm going to do the test for 5 as well, and that's going to fail. And we can see the same as before that if we add another if branch, we can make it work, but it just, we can see this isn't going anywhere. We're going to have to keep adding these. So we can refactor now to leverage the code we've already written, because right now this isn't really using this at all. And we can see that from 5 upwards at least, we're going to be adding i's again. So for example, if we add our test for 6, we know that that's going to be vi, which is currently failing, and there's no point adding another if branch here because, like I said, we're going to go forever. So let's leverage this while loop to add the i's on for us, given that we've already written that code. So what we're going to do is create a variable called remaining, which is at first going to be equal to num, and then we're going to subtract from that as we go. So we know that we need to start at at v if the number is 5 or higher. So we're going to change that to be greater than or equal to, and then instead of returning v, we're going to add v to our result variable. And then we're going to subtract 5 from our remaining variable. So this means that if we pass in a number bigger than 5, we're going to start with a v. So say we pass in 6, we start with v added to our variable, and then we subtract 5 from our remaining, and then we need to change our loop here to be whilst remaining is greater than 0, and then for however much is left after we've subtracted the 5, we add that many i's on. So hopefully this hasn't broken any of our tests. It seems like node 1 crashed, so let's just restart that quickly. None of our tests are working now. Why is that? Our while loop is no longer ending, so we have an infinite loop happening. This should obviously decrement remaining instead, and hopefully now our loop will actually end. Yep, so our tests now pass, which is good. And we've abstracted out some more logic, so this now works for 5, 6, and if we add a test for 7, just for clarity's sake, because it feels quite nice to cover every single number, that should also pass. Okay, I mean, we could even add 8 while we're here and show that our solution still works for that. Now we need to test 9, and this is where we hopefully will get another failing test, so we can refactor our code again. So if we give it 9, we're expecting ix. Okay, and this is where it goes wrong. So we can add another else if, and this time say 9 and ix instead of iv, and that should hopefully it's because we're hitting this. Really, we want this to be after everything else. There we go. So now we are returning ix if 9 is passed in, but again, this feels kind of like we're not really going anywhere. We can see that there's more repeated logic. These two if branches are pretty much the exact same. So there's another pattern that's emerged here that we should hopefully be able to refactor. So we can see that even this branch of the if statement is effectively the same. The only difference really is that these are using equals, and that's using a greater than or equal to. So if we change both of those to be greater than or equal to, we shouldn't have any... Why have we broken our tests? Okay, because these need to be in numerical order. That way everything will work, because otherwise 5 is technically greater than or equal to 4, so we'll just return iv before we even hit the 5 branch. So this way around, yep, all our tests are passing, cool. So we can see that all of this logic is effectively the same. We're checking if the number is greater than or equal to a Roman numeral, and then if it is, we're returning the equivalent, Arabic numeral, and then if it is, we're returning the equivalent Roman numeral. And that's the same for these two, and then this one here is effectively doing the same thing, but it's using the variables above. So we can refactor these to say result plus equals ix, and then remaining minus equals 9, and the same for this. And again, hopefully that's, oops, not 9, sorry, 4. There we go. And now everything still works the same. So these are now exactly the same logic, which means that we, as before, can abstract them into a while loop or some kind of loop. I'm going to use a while loop. Although actually, given that we need a way of mapping these together, I think this is time to introduce a new technique into our solution. So we need a way of our function knowing that 4 is the equivalent of iv, 5 is the equivalent of v, and 9 is the equivalent of ix. So I'm going to create an array of objects to do that. We'll call it values, and it's going to be an array, and then inside of the array we're going to have lots of objects, and there are going to be 2 properties in each one. We're going to have Arabic, which let's say is 9, and Roman, which will be ix. And then we need one of these for each of the values that we're checking here. So 5 will be iv, and 4 will be, oops, 5 is v, sorry, 4 is iv. So now we have an association between all of the Arabic and Roman numerals, which means that we can abstract this away by looping over this array right here. So we can do values dot for each, and then it takes a callback. For each value, we want to do this check. So we'll say if, now it needs to use remaining, the same as our while loop down there, so that it can decrement each time. Otherwise, this line isn't going to do anything to our if statement. So we'll say if remaining is greater than or equal to value.arabic. Oops, that's that touchpad again. So that's the equivalent of this number, this number. If it is greater, we want to do result, oops, plus equal value dot Roman. So that's this line, but made generic. And then we will subtract the Arabic value from our remaining. And that way, as this loop goes through, this number is slowly going to reduce down towards 0, and that's going to work our way towards the correct result. So if I remove these if branches, hopefully this loop is going to achieve the same result and our test should still pass. Yep, and they do. That's great. So we've now abstracted out a load more if branches, and this is now working for all the values up to 9. So let's add another failing test, because we can see that this isn't going to work for 10 because we don't have a 10 value in our array. Yep, 10 isn't working there. So now instead of adding another if branch, we can just add 10 to our array, and hopefully, yep, the test just passed. So that's great. We have an abstracted solution that's working for everything so far, so let's keep adding tests and see at what point they fail, because I don't feel like this is a final solution yet. So 11 should be xi, that still works. It feels like we're repeating ourselves quite a lot in our test file here, so it might be worthwhile maybe abstracting our tests as well into a little loop, just so that we don't have to keep writing this again and again. But I'm not going to take the time to do that now. Maybe that's an exercise for the viewer. And 12 should be xii, which still passes. 13 should be, oops, xiii, that still passes. Now this is, I think, where we're going to have a problem. 14 should be xiv. Oh no, we've written a pretty robust solution so far. So we'll keep adding tests until we hit a failure. 15 should be xv. Now I'm going to jump ahead to 20 because I'm pretty sure, given that the others have passed, the in-between numbers are going to as well. So 20 should be xx. And that's where we hit our failure. Now this is failing because we currently have no way for our function to repeat any value other than I. We have a while loop here, and that's just appending i's once remaining gets down to 0. But really for 20, we want to repeat x. So you see here, we're getting kind of a nonsensical value because this while loop is only working for smaller values, not for bigger ones. So what we really need to do is put this while loop inside of our for each, and that way this will run and it will always repeat any values it needs to repeat. So what we can do is take our while loop from here. Actually, it might be easier just to write it directly in here. So instead of our if branch, we'll say while remaining is greater or equal to value.arabic. We will do the exact same logic as before and remove that while loop. So if I give that a save, something's gone wrong. And why is that? Some of the tests passed and some haven't. Interesting. Our problem is that we've removed the if one repeat I, but we haven't actually added that value to our array of values here, so there is no way for a function now to repeat i's, which is why we're failing on 12 and 13, 11, I assume also, yeah. Okay, so what we need to do is actually add our 1 values to our array. So we'll have 1 and I, and now if we save that, there we go, our tests are passing. Okay, so we have successfully moved our while loop inside of our for each, so that now as we pass any number in, we check against the pairs in this array, and then we slowly build up to our correct result. So say we pass in 14, we assign remaining to 14, and then for each value in here, starting at the top, the highest number, we say whilst 14 is greater than, in this case 10, which it is, we add value.roman, which is x, to our result, so we get x, and then we subtract the Arabic for the x, which is 10, so we are now at 4 for our remaining. On the next iteration of the loop, we're looking at 9, 4 is not greater than 9, so we move on. We get 5, 4 is not greater than 5, so we move on. 4 is greater than or equal to 4, so we then add the value for 4, which is iv, to our result, so we now have xiv, and then we subtract 4, which is the Arabic value, from our remaining, which leaves us at 0. So then we loop through again and again, and this time because it's 0, none of them are going to enter the while loop, which means that we will have a final result returned of xiv, which, as you can see, is correct. So this solution is currently working, but just to make sure, we should probably keep adding some tests for bigger numbers. So I'm going to jump up to 40 now. So 40 should, I believe, be, I want to say XL? I think L is 50 in Roman numerals. Maybe we should just check that against the final one. Yep, so 40 is XL. Okay, so 40 should be XL. Obviously that's going to fail now because our test doesn't know about L. It has no value for 50, which means that it's just going to keep repeating x's until it hits there. So what we need to do is add our value for 40 in here. You can see the pattern emerging now in our array, which is that other than having a value for 1, we're going to need values for each of the kind of keystone values in Roman numerals. So we've got v, x, and we're going to need L as well for 50. And then we also need the preceding value there. So we have 4, which is the one before 5, 9, the one before 10, and 40, which is like the preceding value for 50. And now our test should pass. Yep. And we know 50 is going to pass. So now let's jump up again, and we'll say 90, which should be xc. C is 100. And that's going to fail because we don't have a value for 90 or a value for 100, and we can see from the pattern here that we're going to need that. So let's add those in. 100 is C and 90 is XC. There we go. And now we can jump up again, so we can see that the next value we're probably going to hit here is going to be 400 and 500. So we'll do 400. Now 500, I am drawing a blank on. My Roman numeral skills aren't too great. Okay, is D. So that means that this is going to be CD, 100 less than 500. And if we check that, we seem to have hit a problem. And that's because we haven't added them to our array yet. So let's add 500, which is D, and 400, which is CD. There we go. And we'll just go up to, well, we'll keep going for now, just to make sure we've covered all our bases. So the next one we're probably going to hit is 900, because we don't have anything for 1000 or 900 in there. Now 1000, I believe, is M. Yep. So 900 is going to be CM. Match test should fail because we haven't added them to the array yet. So we will duplicate that, and we will say 1000 is M, and that should be CM. Okay, there we go. And then I think the final one we're going to have to do is 4000 and 5000. Now, there isn't actually a value for 5000 as far as I'm aware in Roman numerals, which is kind of a problem, which is why in the final result here I'm just sending an error message back, because, well, there isn't really an easy way to represent any other numbers. The Romans didn't go that high as far as I'm aware, so I think maybe we can leave our tests here for now. Maybe we'll do one for 4999 just to double check that we're getting the correct result. So we're expecting that. And it passes. Okay, so we work all the way up to 499, and if we wanted to, we could do what I've done, which is just add a quick if num is greater than or equal to 5000, we will return a string saying something like, sorry, the Romans couldn't count this high. Okay, and there also wasn't really a concept of negative numbers in Roman numerals, or 0, so we should probably also have if the number is less than or equal to 0, we'll return a string saying, sorry, the Romans didn't use 0 or numbers lower than 1. Okay, and if we really wanted to check that, we could also just make sure that it's working, and we'll say expected 5000, sorry, actual is 5000 and the expected is that string. let's just say an error there. And we'll duplicate that just to make sure that our negative is working too. And we'll put our error message into the test. And let's just say negative randomize output and too large randomize output. Okay, so we now have a full suite of tests that hopefully mean that no matter what users do when we build our user interface, nothing will break, and they should at least get a useful error message even when we can't show them a proper result. So the next part of this, I'm just going to build a quick UI. So we're going to create our index.html file, and I'm going to use Emmet just to pre-populate all of the standard things. We'll make the title Romanizer, and we're going to need a main with the class of container, and that's going to contain our form, which we'll just give a class of form. Doesn't need an action. And inside the form, we're going to have a label with a class of, actually I'm not sure yet, so let's just have a label. And the label is going to be for our, let's just call it num input. The label is going to say, I don't know, what are we working at? Okay, enter a number. And then we need an input with a type of text. And that input needs an ID to match the 4 on the label to associate them. So we'll say num input. And also this input is going to be required because I don't want people submitting the form without it, as there's no point. And then we need a submit button. So we'll have a button, and let's give that class of form button. And also that needs a type of submit. I think that's actually the default inside of a form, but it's better to be explicit. And let's just give that label of submit. Okay, so we'll save that. And now we will open up in our browser. There we go. We've got our form. It doesn't do anything yet, but that's fine. So what we want to do now is hook this up to our Romanizer function. So this is quite nice because we've got a pure function here that's very testable, and then we can just do our DOM manipulation and call this function when we need to. I'm gonna give this form an ID just so we can select it and call it JSForm. And now we want a script tag with an src of romanizer.js. So that's going to allow us access to the Romanizer function. And then we want another script tag, and this is where we'll just do our DOM manipulation because there won't be much of it, so there's not much point putting it into a separate file. Okay, so first we're going to want to select our form. So let's just use getElement by ID, and we're going to select for JSForm. And then let's just console log that to make sure that we have it correctly. There we go, we've got the form. You can see there is an error here, and that's because we're using module.exports in our Romanizer file. And module.exports is actually a node thing. It's something that the browser isn't going to recognize. So what we can do, just to make sure that error doesn't show up, is wrap this in an if statement. So we'll say if type of module equals, I think it's going to be function, then we want to export something, otherwise we don't. So now hopefully, here we go, and we have no more error. This is only going to happen if module actually exists in the node environment. Just to make sure that our tests haven't broken, which they may have. Okay, what we really want to be checking is that this is not undefined. So we're checking that we actually do have access to module. I'm not sure what I was trying to do before. And hopefully, yep, our tests are running fine, and the browser still doesn't have any errors. Okay, perfect. And we are still selecting our form correctly. So we go back to our index.html, and instead of console logging this form, we're going to add an event listener to it. So we're going to do form.add event listener. We're going to listen for the submit event, which is what's fired when someone clicks that submit button, or if they hit the enter key from anywhere in the form. So we're going to listen for that submit event, and then that's going to take a callback, and that function will take the event. Now inside of here, we want to use event.prevent default, and that's a function on the event that will stop any of the default actions happening. So by default, a form will refresh the page because it's expecting to send data off to the server and then receive a new page to load back. But we're going to do everything in JavaScript and just inject the result right into the page. So we don't want that refresh to happen because that will break our app. So that's going to stop that. And now I'm just going to console log the event.target, which is hopefully the form that the event is from. So just as a test, we'll give it a number. And for some reason, prevent default didn't work. Oh, I didn't refresh the page. Okay, we'll try again. There we go. Just to make sure that did work. Yep, event.target is the form. Now, what we want to get is, I believe, the... Should we try the first thing inside the form? Oh, I didn't refresh again. There we go, that's got us the input. So what we actually want is the value of that input, which in this case is 42. So let's refresh again. There we go, we now have access to the value when the form is submitted. So what we need to do is pass this value into our Romanizer function that we have access to because of this script tag. So instead of console logging that, let's just say Romanizer, and we'll assign that to a variable. We'll say var Roman, or let's call it result, is equal to that, and then let's just log result and see what we get. Refresh, and there we go, XLII, which is 42. So we now want to just put this into the DOM. So we're going to create a div, we'll call it result, give it a class of result, sorry, and actually let's make that an ID. I just prefer using IDs with JavaScript. And then we're going to select it, so we'll call it result, and we'll select the div, and then in here we're going to say result. Oh, that's confusing, we've called them both result. Let's call that one Roman. We'll say result dot text content equals Roman, and hopefully that will stick our result into the DOM. There we go. That's the basic structure laid out now. We've hooked up our Romanizer function to the DOM, and we have everything working as we want to. So now we're just going to write a little bit of CSS to get it looking as nice as this does. First of all, I'm going to write this inline just here again because it's easier than using another file. There's not too much CSS to do. So I'll just leave it here so it's easier to see. So first of all, I'm going to style the container. I'm going to give it a max width of say 40em, and I'm going to give it a margin of 0 for the top and bottom, and then auto for the left and right, which should center it in the body. and then we'll give it padding of 1em, which means that once the window gets smaller, it will at least maintain a 1em space around the edges. So let's refresh that. There we go. I mean, you can't see it because the form isn't full width yet, but if I give it a border, there you go. That's our container. So now let's style our form. Actually, before we do that, browsers tend to be quite inconsistent with inputs and buttons. So I'm just going to do a quick reset to override all of their styles. So we'll say display block, and then we want to make sure the font size inherits, because sometimes you can see buttons have weirdly small font sizes, and also the font family. Sometimes they have strange sans serif families, even when you haven't. Sorry, serif families, even when you haven't set that. So we'll say inherit. Then we'll say color inherit. Just this is to make sure cross-browser consistencies is there. So background none, and we'll just for now say border 1 pixel solid and border radius none as well. So that should hopefully standardize how our inputs look. And refresh that. There we go. Then our display block. That's good. And maybe we want them to be width 100% as well. Okay. Now it's not looking amazing at the moment, but that's fine. This is just a reset. We're not styling them yet. So now we want to style our form. I'm not sure there's actually much to do to the form, but one thing I did forget is it's always useful to set box sizing to border box. This is going to change the box model for the browser, and it's going to keep everything a lot more consistent. So you can see there's some strange things happening over here that, yep, I fixed once I refresh with border box set. And whilst I'm here, I'm also going to set the body's font family. Let's just say Helvetica, Arial, sans serif for now. And let's just make the color a little less harsh. And yeah, that's probably fine. Okay. Now we need to give classes to these two. So let's say form input. You may be wondering what this weird syntax is. This is BEM, which you may have encountered before. So this is saying that the block is form, and then this is an element within that block. So it's an input within the block, and then you can also use modifiers, which is the M. So if I had a different kind of form, I might give it form input, I don't know, primary, and it might have a different color, for example. So we're probably not styling the form right now, but let's say form input. And what do we want the inputs to do? Actually, if we're aiming to have it look like this, what we really need is for the input and the button to be inside of a div. So we'll give that a class of form row. And we'll save that, and that should put them inside of a div. And then we'll use flexbox to make these two sit in line with each other. There we go. And we can probably give form button a margin left, let's say 0.5em, just to space them out slightly. There we go. That's nice. I think it would probably be good for these to have just a bit of padding as well. So let's see. There we go. Okay. Now we also want the result div to be visible even when there's nothing in it, so I'm going to give that a height and a border. Let's say results. Actually, let's say min height. That way it can always expand if for some reason the error messages are longer. So I don't know, let's say 5em, and we'll give that the same border everything else has. Just a 1 pixel solid border for now. Okay, and maybe it also wants a margin top of 1em just to space things out. There we go. Now I'm going to give that button a background color just so it stands out a bit. I like pale violet red, and it's probably going to want a color of white just so the text stands out on there. There we go. And it also doesn't really want a border, so let's say border none. There we go. Okay. Now this row also wants a margin top just to space it out from the label above it. And we're getting reasonably close here. Looks like we want a title, so let's use an H1 and we'll say Roman numeral converter. Okay, we can probably lose the border around the container now. And that's reasonably close, so let's see what happens if we enter a number. We probably want this to be centered. So what we'll do is give this display flex, and then we'll do justify content, center, and also align items center, and that's going to center it both vertically and horizontally. There we go. And maybe we want to bump the font size up a little bit, just so that's a bit more jumping out at us. There we go. And what else are we missing? It'd be good to have some hover styles on that button, and also maybe some less ugly focus styles on the inputs. So let's say form button hover, and we want to darken this button when we hover it. So a nice thing you can do in Chrome's DevTools is you can click on a color when you're inspecting the element, and then if you switch this to HSL, you can actually manipulate the color quite easily. So let's say we want to make it 20% darker, we can change that to 45%, and then if we change it back to the hex code, we can take that and put it right here. And now there we go. We want a transition here, just so it fades nicely rather than jumping straight from one color to the other. There we go. And it would be nice if this focus ring wasn't the kind of ugly browser default. It's important not to just disable this, because otherwise people who are trying to use your interface without a mouse will have no idea what they have selected as they tab through. So let's say form input focus, and we'll say outline 1 pixel solid, no, let's make it sky blue, and we'll see how that looks. Okay, it's not super obvious, so maybe we'll make it 2 pixels. Okay, and then I think I'm going to use outline offset and give that, say, -4 pixels, and that way, oops, sorry, not minus, +4 pixels. There we go, and now it's a bit more obvious, and then that should actually be for both. We may as well share those styles, so we'll make it for, oops, form button and form inputs focus. There we go. And something else we can do just for a bit of user experience is, since there's no reason to be on this page unless you're entering a number here, we're going to add autofocus to that input. And that means when you refresh this page, that will automatically be focused, so you can just start typing straight away. And one final thing, I've just realized this is an input class of text, and that means that we're allowed to enter anything, in, even not a number. And that's something we haven't even accounted for in our error handling, so maybe we should go back and fix that. but for now we can just make that input type number, and now I'm trying to type letters in, but nothing until I use a number. So there we go, that's pretty much matching what I had as the end result there. So maybe just quickly it will be useful to go back and add a test for if we pass in anything other than a number. So let's say we give Romanize a string, and what do we expect? Let's say, sorry, I can only convert numbers, and we'll say we should output an error. And that test fails because if we give it a string right now, it's going to throw an exception because we haven't accounted for that. So what we should have in here is another check just to make sure we are really giving it a number. So we say if number does not equal number, return there. Interesting. Now all our tests are failing. Of course, we need to be checking the type of number. There we go. Now all our tests pass, and hopefully that's covering. Our test coverage should be good enough that bugs won't arise when people are using our product here. So thanks for following along with me. Hopefully you've learned something about test-driven development, and yeah, I'll see you next time.